We use the symbol phi to stand for the golden ratio. Remember that 1 plus radical 5 over 2, or 1.618, is an approximation that we use for the golden ratio. The golden ratio is an irrational number, and we can do an activity with our calculator that will help us to approximate the golden ratio. So I'd like to have you do this with me. So if you will get your calculator, we need to remember what reciprocal means. Reciprocal means that we're looking for the number when we can multiply the two together and get 1. So 1/2 and 2 over 1 are reciprocals, because 1/2 and 2 over 1, when multiplied together, will give you 1. 3/4 and 4/3. When multiplied together is 12 over 12, which gives you 1. So we're going to be using the term reciprocal as we do our calculator activity. So we're going to begin with the number 1, and we're going to add 1. That gives us 2. We're going to take the reciprocal of 2, which is 1/2, and we're going to add 1 to that. I'm going to math, fraction, enter, and the fraction for 1/2, 1 1/2, or 1 5/10, is 3/2. So I'm going to take the reciprocal of 3/2, which is 2/3, and I'm going to add 1. Now if I go to math, enter, enter, I get the decimal changed to a fraction, which is 5/3. I'm going to take the reciprocal of 5/3 and add 1. I'm going to change that to a fraction, which is 8/5. I'm going to write the reciprocal and add 1. Change that to a fraction, write the reciprocal, and add 1. I'm going to change that to a fraction, write the reciprocal, and add 1. So you can see that the more times that I do that, the more I am approaching the golden ratio. So it's an activity that you can do to approximate the golden ratio. we give the students a little practice on working with fractions and getting the terminology together on reciprocal. And all right, we now are going to look at some rectangles. And we say that rectangles that are of the golden ratio are the most pleasing to the eye. So you have three rectangles. So if you think of a picture hanging on your wall, which one of these three would you think would be most pleasing? Or which of these do you think have sides that are of the golden ratio? So pick A, B, or C. And if you picked B, then you have found the one that most approximates the golden ratio. When we look at A, this measures 8 centimeters and this is 6 3/10 centimeters. So the ratio is about 1 3/10. On B, this is about 8 5/10. This is about 5. So that gives you the closest to the golden ratio of the three, because this is 8, this is 3 2/10, and that gives you about 2 5/10. So as you look at these three, kind of get that this is more likely to represent the golden ratio. We say that the golden ratio creates, or the sides of a rectangle that is in the golden ratio is very pleasing. And artists like Da Vinci used that fact in some of his artwork, like the Mona Lisa. So if we look at her face, you can see the rectangle that surrounds it, and so the proportions of her face is one part that represents the golden ratio, but there are other parts of her body that also represents the golden ratio, and I'm going to leave that as part of your research project. In your research project, I would like for you to look up the golden ratio as it is used in the real world. And so I'd like for you to write no more than a one-page paper about where you can find the golden ratio in our world. Now we are going to make the golden rectangle. We will begin with a square that is 2 inches on a side. So we're going to measure. We have 2 inches. I'm going to get my right angle. And to make it easy, I'm going to use my compass and measure a radius of 2 inches and then mark that to get the height I need. So we have A, B, C, D as the square. I'm going to find the midpoint of AD, and it's going to be easy since the length is 2. I'll just mark the 1. And that is E. I'm going to connect E to C. And you should recognize what the length of this segment is. If this is 1 and this is 2, this is a right triangle. Then remember this would be the square root of 5. I'm going to extend AD with my compass. I'll measure a radius of EC, and leaving my compass where it is, I'm going to make a circle. Whoa. And position F. I have to have a right angle at F, so I get my right angle. I make the segment, and I need it to be 2 inches, so I'm going to get a radius of 2 inches and mark that on the segment and connect that to C. And that is G. And what you have now is a golden rectangle. So you have a square. We found the midpoint of the side, connected that to C, used that radius to make circle E, that located F, that we made perpendicular, and that created the golden rectangle. Now what's really cool about that? This is a golden rectangle as well. And what I want to do is take out the square that would be of length DF. So we're working on now taking our golden rectangle and making it into a golden spiral. So I'm getting the side DF, make a circle at F and a circle at D that are congruent. Connect those, and that takes the square out of the original rectangle. Call that G and H. What I have left when I take out that square is a golden rectangle. So now if I take out the square, that would have sides GH. So I'm going to measure that here. I'm going to mark that on H and on G and connect. What I now have is the square that I have taken out, and I have another golden rectangle. So now if I take out out of this rectangle, I take out the square that is CI in dimension. I'm going to take out then I now have another golden rectangle. And if I take out the square that is whatever, LJ, I now have the setup for making a golden spiral. And this is what you would do. I'm going to begin at B, and I'm going to make my curve. So for each square that I took out, I will curve to the opposite vertex. So from H, I will curve to I. From I will curve to K. And from K, I will curve to here. And I could continue, if I continued taking out squares from the golden rectangle, I now have the golden spiral. And we see the golden spiral in nature. So in your research, I would expect that you would include examples of the golden spiral.